Welcome back, everybody. I'm Travis with Linux Academy. In this section, we're going to learn how to use the Dockerfile to go and create images. Docker is able to go and build an image by reading the instructions out of a Dockerfile. And the instructions are nothing more than commands users can execute at the command line to build an image. And a Docker image is a collection of read-only layers, with each instruction creating a layer. These layers are going to be stacked on top of one another. Each layer creates an image, and these layers are going to be deltas of changes from the previous layer. When going and building an image, we use the Docker image build command, passing in any flags that need to be used along with the Dockerfile. So here's an example of a Dockerfile. The first layer is going to be created using the from instruction, and every single Dockerfile is going to begin with it. This tells Docker what the base image is going to be. The copy instruction is going to go and add files that are in the current directory of the Docker client, and it's going to copy the files over to the container's destination. Next, the run instruction is being used, and we're executing make. And the final instruction is cmd. This is going to tell the container what command to run when it starts. Now, when it comes to building Docker images, there are some best practices you should adhere to. The first one is making sure that you keep your containers as ephemeral as possible. And by ephemeral, what I mean is you can go and stop and destroy your container at a moment's notice and create a new one to replace it with very little effort. We want to make sure that we follow the sixth principle of the 12-factor app, which is about processes. Execute the app as one or more stateless processes. 12-factor processes are stateless and share nothing. Any data that needs to persist must be stored in a stateful backing service, typically a database. We want to make sure that we don't add any bloat to our image, so avoid using any unnecessary files. All this will do is just make the image bigger. And the way we can avoid having unnecessary files getting copied over to the image is by using the Docker ignore file. This is very similar to git ignore if you use git before. In the Docker ignore file, all you have to do is supply a list of either files or directories you want excluded, and when the image is built, those files won't get copied over. As a Docker 17.05, you can use a multi-stage build to reduce the size of your Docker image. In a multi-stage build, two Docker images are being built from one Docker file. The first image is used to create your build artifact. This will include all the tools that are necessary to build your image as well as test it. The second image, which is the image that will be created, is where you copy your build artifact to. And this image will only have the necessary binaries and libraries to run your application. And this will greatly reduce the size of your image. You also want to avoid installing any unnecessary packages. This will also contribute to the size of the image. Anything that you see as being nice to have, don't include it in the image. Each container should only have one concern. This means we decouple the application. Let's use WordPress as an example. We don't want one container that is running WordPress along with the database. We would decouple this by creating multiple containers. One for the WordPress application itself, and another for the database. And possibly we could be using Memcache as well as a load balancer, so those will be run in their own containers as well. Now, prior to Docker 1.10, it was very important to keep the number of layers to a minimum, and it's still a best practice, because as we add additional layers, we do add additional size to the image. And a good way of reducing the number of layers is by using multi-stage builds. If you're using multi-line arguments, make sure that you sort them alphanumerically. This is going to help make your Dockerfile more readable and a lot easier during peer review. Also, it's a good idea to have a space before your backslash. When Docker goes to build an image, it's going to step through each instruction in order. And because each layer is its own image, Docker is going to go and look for a cached image. And if it finds that cached image, it's going to go and reuse it. Optionally, when you're executing a Docker image build, you can use the no cache flag and set it to true. And this will go and ignore any of the cached images. Now that all this is out of the way, we're ready to go and build our first image. Go ahead and mark this lesson complete.